Is David found here?
Yep.
So I'd like to introduce David Found, VP of Software for, is it Levio? Levio Consulting, talking about modernizing your organization, starting with enabling real-time solutions.
Perfect. Thank you. Well, welcome. And I broke it. There we go. My name is David Found, and I've been leading several key initiatives for financial institutions over the past 12 years with Levio and its most recent acquisition in Delian. Today, we're going to dive into the concept of modernizing your organization, really from a technology perspective. It's so important because customers today are not only demanding real-time payments, but real-time everything. Notifications, alerts, feedback, advice, payments, etc. And so this session is going to be geared at anyone looking to modernize their organization. I'll be speaking from firsthand experiences as we recently implemented one of our clients onto the TCH RTB network. This unlocked a brand new set of capabilities for them in the real-time payment space. We're going to explore some of the ways technology is used and misused in modernization efforts. We'll discuss six critical success factors at a high level, but we'll dive into two specifically, hybrid integration and observability. So at a high level, these critical success factors apply to any modernization project. So availability and resiliency. How robust is your application? What happens when something goes wrong? Panic or automatic recovery? Hybrid integration. We'll discuss this one in more depth, but are you leveraging existing systems? How are you managing latency and interdependencies? Security. What's your approach to security? Defensive? Offensive? Both? Have you adopted a shift left mentality so you can review and audit all changes across your systems? Cloud optimization. When's the last time your AWS bill came in at the originally estimated target? Do you leverage any type of automation for cost control and mitigation? Observability. This will be our second success factor we'll explore more. But what does your transaction visibility look like? Are you able to narrow in on a single transaction through all your interconnected systems? How quickly? And operations. How is your SLA adherence? Are you achieving 4 or 5 nines of uptime? Can you hit 6? You can't do it without automation. So in your operations playbook, what's currently not automated? So let's dive into our first challenge, hybrid integration. The reality is that 98% of organizations still leverage some form of on-prem systems. At the same time, cloud adoption is expected to grow to an $830 billion industry by 2025. So your modernization efforts need to incorporate the cloud in some way. But what challenges exist because of this hybrid integration? So there's latency and SLAs. Physical geography can play a big role. Do you have a dedicated pipe? What does your failover look like? What is your uptime target? And what's your uptime that's actually achieved? Limited interoperability of on-prem systems and legacy systems. That requires more processing upfront, and that cuts into your SLAs. Transaction visibility. When, not if, something goes wrong, can you still get to the source of the issue in a distributed system? How easily? How quickly? Good management practices, such as the principle of least privilege, can cut into efficiencies and even understanding. Does restricting that access hinder your visibility? Integration testing. In larger systems, you're bound to have competing priorities. Systems should implement low coupling, but does your path to production? How much inter-team dependence do you have? And how do you build better team cohesion? How much knowledge sharing can flow fluidly across your different teams? Is it business knowledge? Is it pseudocode? Is it shared libraries? The tech stack and experience make a big difference. Let's explore some of the solutions to these challenges. When it comes to reducing your latency and achieving your SLAs, are you equipping yourself well? Asynchronous versus synchronous. What can be performed in parallel? For us, performing fraudulent account checks and checking the available balance of an account are an example of parallel processing. Our scalable cloud services reach out to multiple on-prem systems in parallel before aggregating a response back to the message originator. Do you consider what actually needs to be performed before you respond to a message? For example, leverage tools like Kafka to process asynchronously what isn't part of the critical path. Its producer-consumer model is perfect for email and notification handling, auditing, data aggregation, etc. Another aspect of ensuring low latency is becoming a high-performing organization. Adopt a phased modernization approach to avoid being part of the 66% of software projects that fail to meet objectives, timeline, or budget. Always start small, be agile, and iterate on your approach. Our DevOps organization sees much more success in the teams that measure lead time, the time it takes to get code into production, change failure rate, the percentage of deployments that cause a failure in production, deployment frequency, how often you deploy to production, and mean time to restore, how long it takes to recover from an issue in production. If you don't yet, start tracking these. The trend lines alone will tell you which way your organization is heading. Without this approach, your feedback cycle is broken, so the time to address any latency you didn't plan for becomes very costly. The next problem area is with transaction visibility and data visibility in general. The data may be business data such as transaction volumes or amounts, or it could be more functional data such as logging or response times. Regardless, you need a single source of truth. You should still be practicing the principle of least privilege, but this needs to be a shared understanding across all teams and stakeholders. Also, leverage automation with ETL data pipelines to produce consolidated dashboarding and reporting. Distributed tracing is also important in any sort of distributed system, and it's extremely painful if it's not implemented at all. Imagine you've got a beautifully architected microservice architecture with 5, 15, 30 microservices all doing their one job really, really well. And even some legacy on-prem systems as well. How do you answer what happened to this transaction? Distributed tracing allows you to follow that transaction through each microservice and on-prem system while recording data and collecting metrics along the way. Coupled with centralized logging, you can enhance both manual and automated troubleshooting and alerting. And now think of that exact same problem without centralization. Are you going to painstakingly open the logs of each microservice? Save time, save money, invest in proper visibility. The last significant challenge with hybrid solutions is integration testing. Typically, your teams themselves are distributed and with competing priorities, but I'd like to share a couple of key differentiators that I'd happily discuss afterwards in more depth. First is consumer-driven contract testing. This flips testing on its head compared to traditional ways of thinking. Instead of the producer or the creator of the API being the one who writes all or most of the tests, that is distributed to the consumer or the user of those APIs. The natural end result of this practice is you end up with well-documented, given that then, types of test cases because of the handoff between the teams. It also ensures compatibility with integrations before you release, because the team that will be consuming the API has already provided the test case along with data and it must be adhered to. This is different than sharing a spec in that you can catch differences earlier, such as date validation or date formatting issue. Have you been part of any projects recently that had core functionality fail once they were actually deployed, even though all the unit tests were passing? Another key element to distributed systems is implementing service mocks. For every service that is interacted with in our real-time payments implementation, we have a data-driven service mock. This allows for a more robust end-to-end testing with a variety of levels of real versus mock services in the overall environment. In our case, this is a shareable library that is used across our clients and projects to expedite our team's testing efforts. It's also a key driver in consumer-driven contract testing because each service we mock and the scenarios we provide to our service mocks is the foundation for our test cases that we provide to the creators of those real services. The next critical success factor I'd like to discuss is observability. We see some challenges that overlap with hybrid integration, but we'll explore them from a slightly different angle. Traceability, which we've already touched on, but obtaining that visibility throughout distributed systems can be difficult. Metrics, needing to define metrics that actually align with business value and ROI. And investment, being able to see the value that will come with being able to deliver on and improve those metrics so that observability isn't ignored. The first key solution is picking the right tools. I'm not going to pitch for any of these tools specifically, but I wanted to share some of the platforms that help contribute to observability efforts. The main takeaway is thinking about your real-time systems. Monitoring. Do you have monitoring in place? Are you collecting metrics? Are you being alerted of issues or downtime? Are you getting false positives in those alerts? Logging. Have you invested in centralized logging? Or are you using unstructured text logs, or are you benefiting from structured logs with search capabilities? Tracing. We've discussed this already, but this isn't just about microservices and distributed systems. Can you follow a transaction through your systems with code level details? How deep does your tracing go? Visualization. Can you take the data that your system is constantly generating and present it back, such as response times and rejection rates, and present it back in a meaningful business way? Who has access to this data? Is it actionable? Now that we've got the right tools, measure what matters. We need to be creating SLOs, service level objectives, which relate to business success factors. Some common ones in a transaction processing system are response time, throughput, availability, and failure or rejection rate. Are you penalized if you fail to meet a particular SLA? That's a good place to start. How can you increase your ROI? Perhaps by reducing the number of rejected transactions. Track it. In our implementation, we have a response time SLO of less than 5 seconds, a warning range of 5 to 10 seconds, and an error state of anything above 10 seconds. Using Dynatrace, we incorporated alerting based on median transaction time and are able to view the processing time over any specified interval, such as the last hour. I'm also going to re-echo the 4 key DevOps metrics that make you a high-performing organization: lead time, change failure rate, deployment frequency, and mean time to recovery. These are critical to success, and we'll explore more on the next slide. And make it visible. I covered that on the previous slide as well, but I cannot stress it enough. So now that we've got the right tools, we're measuring what matters, let's iterate. This is why those 4 key DevOps metrics are essential, and if you'd like to know more about them, let's chat afterwards. But they are what allow you to iterate and improve. The screenshot below was taken from Dynatrace, and because we have distributed tracing on, we see immediately that a call to a particular on-prem service took about 12 seconds. Immediately, we were alerted about this because it exceeds our 10-second error rate. And then our operations team can provide all the transaction details, including a trace ID, to the team responsible. This particular issue was reported, investigated, discussed, fixed, and deployed all within a week. Observability provides the means to operationalize investigation, both proactive and reactive, reducing the cost and constraint of your engineering resources. So just a few key results of this project. We deployed a cloud-native, multi-region, active-active microservice architecture, which integrates into the TCH RTP network and several on-prem legacy services. We achieved month-over-month transaction growth of nearly 200% without succumbing to any SLO warnings or errors. We've continuously made performance improvements to further reduce transaction time by 70% since launch. This didn't happen overnight. This has been the result of dozens of releases aimed at improving the system over and over each iteration. Thank you for your time today. The other half of this conference is, fraud and anomaly detection. We'd love to chat with you afterwards with me or my colleagues, but I appreciate your time. I know it was a different angle to be very technology focused, but that's who I am. So I'd love to chat with yourself or anybody else who might be of interest. Thank you.